ahead and with the introduction. So, hello, for those who are on the call. I'm Renata Rawlings-Goss, the co-executive director for the South Big Data Hub. I'm here at Georgia Tech, but my counterpart is Leah Shanley at UNC, University of North Carolina, Chapel Hill. We're going to be talking to from two different perspectives. Actually, a speaker from Georgia Tech and University of North Carolina, Chapel Hill, which isn't always the case, but that's how it turned out this time for the Smart Cities. From Iris Penn, who is in our School of Civil and Environmental Engineering here at Georgia Tech, and also from Core Rademaker. And I'm going to have my student here who is working with me at the South Hub talk about the speakers. I wanted to give a brief overview about the Hub to people who maybe are more or less familiar with it. So the South Hub is 16 states, Delaware through Texas, including D.C., and we focus on big data partnerships and also bridging silos across big data and data science projects. So in different areas, looking at infrastructure as well as how different groups can interact and do projects. We have spoke projects, which are funded at $1 million each, planning grant projects at $100,000 each,
okay.
Do calls like this, communities, and for smart cities. Workshops that will be planned for smart and connected cities and campuses. So I wanted to go over to Arjun to introduce our speakers.
Thanks, Renata. This is Arjun. I'm working at the South Big Data Hub out of Georgia Tech, helping Renata. All says these. We have two speakers today. I want to give a brief introduction about their history and a little bit of what they will be talking about today. We have with us Iris Tien. She joined the faculty in the School of Civil and Environmental Engineering at Georgia Tech in 2014. And after she received her PhD in Civil Systems Engineering from the University of Berkeley in 2014. She also received her Master's in Civil and Environmental Engineering in 2010, and she graduated with high honors from UC Berkeley. She also has a unique interdisciplinary background that encompasses traditional topics of civil engineering, data analytics, signal processing, and all these helps decision-making under uncertainty. And today, she will be talking about integrating data across sources to detect disasters and critical infrastructure failure events. That is her topic. She'll be going before.
Is that the handout?
Yes.
All right. I'm going to go ahead and get started. I'm going to set a timer for myself, so hopefully I'll stay within time. Thanks everyone for joining the call. And today I'm going to be talking about some of our work that we're doing in integrating data across different sources to detect infrastructure failure events. As Renata and Arjun said, I'm in the engineering side of things rather than CS, so hopefully I'll bring a little bit of a different perspective, but in using big data for civil engineering applications. So a little bit about the motivation behind some of our work. So we're looking at infrastructure systems that provide critical services to a community, so things like water, power, transportation networks. And one of the challenges in looking at these infrastructure systems is that a lot of them lack continuous physical sensor monitoring to be able to detect damage or failure events. So whereas things like maybe the transmission grid, which is shown here, maybe the grid is probably the most advanced in terms of monitoring, but if we go to things like pipelines or networks, a lot of these are really old legacy systems that don't have maybe all the sensor monitoring in place that we would want to be able to track performance over time or how these systems are reacting to different disaster events that might happen. In addition, a lot of these systems are very large and they're very complex. They have a lot of different connections and they're spatially distributed. And so the overall idea is what can we do to know more about these systems in real time to be able to minimize the negative impacts of any sort of failure events that might happen, as well as to accelerate our ability to recover from these events with the idea of resilience in mind and bouncing back from different disasters and disruptions. How can kind of real-time knowledge and information about these networks help us recover quicker from any downtime that might happen. So the approach that we're using is to integrate data across different sources to detect these disasters and infrastructure failure events. So the two main types of data that we're looking at is one we call social sensor big data, and then one is physical sensor data when possible. And so social sensors are things like social media data that I'll talk about in more detail coming up. So we did an initial study to see if this is even possible. So the objective is to demonstrate some ability to detect infrastructure damage events using social media data. So we used Twitter data in particular. We looked over a 1 month period to see if this is something that can even be done. As probably most of you know, social media data has a lot of noise in it, so is there a way to actually get rid of the noise and come up with relevant, actually useful information from that data? And so in doing that, we developed this data filtering methodology, which I'll talk about in the next slides. So this is the overall method on the left. So we start with our social sensor, in which case this is Twitter. So we take all the tweets over a time period, and then we do a 3-step filtering process, which is shown in the second box there. And in this filtering process, we first filter all the tweets using search terms. So we include by search term, and then we have stop words where we exclude by stop words to filter out some of the noise. And then the fourth step is the third step of geolocation. So we use some natural processing algorithms and geocoding to be able to then assign a given tweet to a given cell, which we map onto, we map a grid onto the surface of the Earth to be able to map specific tweets to specific locations. And then from that, we are wanting to do our event detection, where we're looking at bridges, highways, gas lines, and power. And so we assess all the tweets in a single cell to identify damage and failure events for these 4 particular infrastructures that we looked at so far. And so in doing this, an example of some search terms and stop words for these 4 different infrastructures are listed here. So for bridges, for example, we were looking at bridge collapse or bridge damage. But of course, when the term bridge appears somewhere, it can refer to a lot of different things. So for example, friendship is like we built a bridge across a relationship or something like that. So those are things that we definitely don't want. And so there's this process of including things in search terms and excluding with stop words. And after that, then we're able to take then the tweets that we have left over that are relevant, and we want to be able to visualize that data. So as an example of this data visualization from that 1 month period that we were looking at, on this plot, the tweets are in blue, and then the detected events, we're looking at bridges specifically here, are in yellow. And in this case, we found a lot of data around Johannesburg on October 14th, which turned out to be a bridge collapse event that happened at that time. And different geolocations came up, so different terms that actually refer to the same event, which is something that we're working through now in terms of how do we actually geolocate these tweets to the level of specificity that we want. So we have the city of Johannesburg, but there's a district called Sandton District, and then it's on Grayston Drive. So all of these terms together actually refer to a single event. But at least we were able to see this, and people were talking about it on Twitter to be able to detect it. Next, I'm going to show some results from these highway events. And so what was kind of interesting here, so this is data from California, is that we found data available both in more densely populated urban areas, so like San Francisco Bay Area is definitely going to be much more densely populated than kind of more in the Central Valley, and even going into more rural areas such as the Valley, or there's some results near these mountains. And so it was kind of good to see that we were able to detect these events in both urban and rural areas. And then the last visualization result that I'll show is for the power network, and this is showing that kind of the global, because social media is global now, that we're able to detect these events across the world. And so there were particularly, this is the U.S. and then also in Puerto Rico on October 23rd. There's an outage that we were able to detect there. And there were these kind of large-scale events across all of Puerto Rico on the 23rd, then also smaller-scale events like at local elementary schools and things like that that we were able to detect. And so now I wanted to show just as an example of what these different filtering steps do to filtering efficiency. And so in this first column here are the number of tweets that related to each of these 4 infrastructures among Twitter users during that time period. And then in the second box here, I'm showing the percent of tweets remaining after we filter out by stop words. And so as you can see, there's actually a lot remaining, and there's we've filtered out we've actually kept most of the data, but there's still some that we filtered out that we want to filter them out because we want to minimize any sort of incorrect detections of damage events or false positives. So even though there's kind of low amounts of noise, those are still important to filter out. And then this last column here for geolocation. So here we see that we actually lose a lot of data here because we need the geolocation information to be able to actually use information from any one of these tweets. And so for Twitter data, for example, most people turn off their location services, for example, when they're doing it. And a lot of locations that are associated with users might not be their actual locations. And so this geolocation step is definitely one that we're continuing to work in and is important to keep in mind as we're looking at these different data sources. And so now I want to shift a little bit to work that we're doing now in terms of, so now that we've shown that we can kind of do this detection of infrastructure failure events with social media data, now we want to see how integrating multiple data sources works. And so now we're looking at specific infrastructure damage due to specific disaster events, where we want to maybe first detect our disaster, locate it, and then tie that event to the resulting infrastructure failure. Where now the overall objective is that we want to see if we can initially detect and then later possibly predict infrastructure damage so that we can maybe proactively take some precautionary actions in anticipation of any impending disasters that might happen. And so this is kind of in the beginning stages now, but we're looking at Hurricane Matthew and Louisiana data from last August. And so now we're looking specifically kind of thinking about what types of events would be of interest. So initially we were thinking maybe power outages, but really power companies and utilities track outages pretty well. And so what was something that that is maybe not tracked as well. And so we thought about flooding in terms of the availability of maybe some physical sensor data, but then also integrating it with our social media data. So for flooding, we're looking at stream gauge data that shows, and I'll show this on the next slide, stream flow and gauge height over time, and then combining that with our Twitter data. So here for the stream gauge data that we're looking at, so the first variable that's tracked is stream flow. So here's an example. So sorry for the small font on the axes, but on the x-axis here is going to be time. On the y-axis is going to be stream flow in cubic feet per second. And so we're looking at over time, and so you can clearly see a spike there, which is when the hurricane hit. And then we're also looking at gauge height, which shows a little bit more peaky, but we see definitely a peak at a certain date. And so we can do that for multiple stream gauges across the area that we might be interested in. And so looking at this, and we identify a specific time. And so here we just identified August 13th as the beginning of flooding. And so then with that, then we can take these stream gauges that we have this data from, and then track the flooding dates across all the gauges, and then plot them with our Twitter data. So on this plot here, we're showing Louisiana, and in blue are the stream gauges, the location stream gauges that we're looking at data from. So these are stream gauges that have detected flooding, and then the magenta points there are then geolocated tweets that relate to flooding from that particular date that we've identified from the stream gauges. And so here, marking to specific stream gauges that we looked at on the previous slide, and we can zoom in, for example, on a specific city and say Baton Rouge, and look a little bit more closely at where flooding has been identified based on the stream gauges, but then also where flooding has been mentioned in tweets, and then ultimately to tie that to infrastructure damage. And so kind of ongoing work that we're doing now in the Boston space, which is why I'd be happy to hear kind of feedback from you all in terms of opportunities moving forward. But we're wanting to now go from the disaster events, so from the flooding to then the infrastructure failures, possibly looking at the same ones that we've looked at previously, so bridges, highways, and gas lines, and possibly power as well. And one of the biggest challenges that we're looking at now is specific locations and the types of damage that have occurred. And so in a lot of cases, tweets might mention a specific city, and that might be relevant for more regional assessments, so you know that there's some sort of infrastructure failure or flooding that happens in a specific city. But really what's going to be the most useful is to know, say, what specific intersection has been flooded, or what specific gas line might have a break, or water main might have a break. And so to move from the community then to the specific intersection, you really have to kind of, in working with this more, have to almost go down to an individual scale in terms of reporting or being able to collect information about these specific intersections or specific locations. And so that's something that's kind of been interesting as we've been doing this work, is that it's relatively easy to kind of get these kind of high-level assessments of damage, but if we're wanting to really look at an infrastructure network and specific components in that network, we need a lot more detailed information. And so we're starting to now work with some communities in Atlanta as well to possibly collect very specific infrastructure-related data under these sorts of disruption events. With the overall idea is that we can kind of be more specific. We can both minimize incorrect detections of damage events and also increase the resolution of the relevant information. And so the kind of societal and economic impacts of that is that if we're looking at wanting to maybe prioritize dispatch of repair crews or how to distribute emergency responders after disaster, we have to really know where exactly to send them. It doesn't really help to just have a city or maybe even a specific street, but if we can say a specific intersection, that would be a lot more useful. And then also in terms of societal kind of policy type impacts, if we want to have any sort of infrastructure closures for safety based off of this information, then there's a lot of questions about how accurate does the data have to be to transition from some sort of assessment to actually action. And so when we're using this type of data, this type of big data that might have a lot of noise and might have some level of inaccuracies or false positives, how do you balance that with maybe public safety or public resources, and how accurate does your data really have to be able to use it to support decisions? And so with that, I just wanted to acknowledge this work is funded under an NSF grant under the CRISP program, so that's the Critical Resilient Infrastructure Systems and Processes program. Thank my research groups. I'm here in the middle, and these are my PhD students. This work is mostly work that Cynthia Lee is doing, second from the left. And I'm happy to take any questions now, and if you want to contact me in the future, my email is listed there. So with that, I'm done, and I'm happy to have any questions and look forward to the discussion. Thank you.
Thank you.
Thank you, Iris. I had a quick question, actually. I don't know if we could open it up to other people, but how did you get the stream gauge data you got from?
So it was actually from USGS. Actually has the stream gauge data available. So that was definitely one of the things that we were looking at, like what publicly available data is there. So we've also looked possibly at the NASA rainfall data as another source, but it's a little bit harder to work with. So the stream gauge data right now we're looking at is from USGS.
Nice. And have you seen there's a NOAA data set that they put up on Amazon that is got a lot of the weather information as well? I don't know all the things that are in.
Can you say that again? The NOAA data set through Amazon that has what type of data?
So they put up a large amount of the NOAA data has now been uploaded to cloud providers, Amazon, Google, and also a community cloud provider where they're trying to make more public use of these data. So I don't know all of the data sets, but I know that they do radar data and other types of weather-related data, usually big data sets. They want them to host these large data sets.
Okay, yeah. And I haven't looked at that yet, but that's definitely something that we'd be interested in looking at. So yeah, we'll definitely look at that more closely. I think with the radar data, it's like the other element that we've been thinking about is kind of the temporal element. So kind of as these storms progress, going from rainfall to stream gauge to flooding in a city, there's kind of this delay, and something that we're kind of looking at now is the timing of these things and when do the tweets actually start to happen, and what's the time relationship between each of these data sets.
Yeah, all right. I also had a quick question. First of all, thanks a lot for your presentation. It was very informative. I saw on your deck that you were talking about using Twitter as means of collection data, and I wanted to understand if there were any measures that you had taken in place to weed out incorrect data.
Yeah, so that was the filtering idea, the filtering methodology was the idea of weeding out the irrelevant tweets, pretty much. And so the initial kind of search term is our initial first filter, and then we have these subsequent filters to try and filter out the irrelevant information. Because there's definitely a lot of tweets that might mention words that seem like they would be relevant, and we look into it. They aren't. And so we're kind of building a machine learning algorithm now, so hopefully kind of once we've filtered these initial ones, that it would then learn which types of words are more likely to be relevant tweets and which ones are more likely to be irrelevant. But absolutely, that's definitely like one of the big challenges in dealing with this type of data.
I was thinking that also if people are tweeting the correct information, but about the location is not correct, how do you figure out, to get the right location, but the information is true of the neighboring area?
Right. So for right now, unfortunately, for those, the location is not specific enough for us to be able to geolocate it, then that tweet is actually, we're not using that one. So that's why there's such a kind of a big portion of the information that's lost. But there are definitely considerations in terms of you can be tweeting about a historical event as well, and how do you separate those from the current event that we might be interested in, and other considerations like that.
All right. I want to open up, if other people have any questions, please feel to ask. And we also have provided a HackPad link. If you guys have any additional notes or questions or comments, please feel to use that medium of communication as well.
Hi, this is Beth Zittler. Iris, thanks for the talk. I work in international development for the U.S. government, and we're constantly interested in learning more about our infrastructure investments, both after we've built them, which is a little easier, because then if we want to invest in monitoring equipment, we can't guarantee it'll be maintained, but we can at least put it in. But we're also curious about, on the planning side, learning from learning about infrastructure that already exists across a partner country. And what I was wondering is, with your research, do you think the main value is in understanding how to set up the system appropriately to, do the filtering that you did with the social media, or do you think that that the historical analyses are more valuable? And I was also wondering if you've published your code openly, and if engaging with other coders and kind of public data scientists is of interest to you.
Sure. So speaking about the historical versus the maybe the planning side thing. So certainly something that I thought a lot about in terms of the progression, and I think both are valuable. I think for existing infrastructure, there's so much of it that we just don't know. Like a lot of utilities don't even ground type things, and so being able to and it's just not financially feasible to physically instrument all of these individual components that we might be interested in. So I think from existing infrastructure point of view, I think to be able to do this real-time tracking, where after you've kind of built maybe a database of how these systems have performed over time, then hopefully you might be able to predict, to do the prediction for an existing system under different types of scenarios. So maybe you know a storm is coming, then you know these areas are more likely to fail, so you can kind of prepare for that and distribute your resources accordingly. But then I also think that we can learn a lot from our existing infrastructure in planning new infrastructure. In talking with a lot of utilities, I think for the planning, a lot of it is just pretty much based off of demand and where they need to service their load. But I do think there's a place for maybe more, in my area, I would call it like reliability-based design, so to ensure higher levels of service under all scenarios, rather than just to maybe service a load at one time, but actually looking over the possible events. The historical analyses would potentially inform the planning process.
Great, thank you.
And I guess you also asked about our code, and so we have a conference paper published on the filtering methodology overall. We haven't made public the actual code to do the filtering, but it's something that I'd be happy to think more, just talk more about to see how that could be facilitated.
Great, thank you.
Yeah.
Any other questions? Okay, I think we're gonna move to our next speaker now. Our next speaker is called Rademaker. He's active with the UNC, creating a platform for smart and connected communities. He teaches courses on smart cities and is a project coordinator for the North Carolina Smart and Connected Communities Initiative. With his company, StarTech, Mr. Rademaker has closely cooperated with the University of North Carolina on smart city programs for students and professionals, Smart City Day at the UNC Clean Tech Summit, and has worked with both successful cities and rural small towns. He holds a Master's of Engineering on Urban Planning and Design from Tilburg and Masters of Science from Regents University, Utrecht, and an MBA from Erasmus, Rotterdam. And today he's going to be talking about towards the North Carolina Smart and Connected Communities Initiative.
Thank you. Thank you. It's difficult names, those universities, huh?
Yeah.
Well, I think you mentioned it all. I stated it here, so let's move on. Smart and connected communities. We promote sustainable social and economic development across urban and rural communities. What you see in general is that, and that's a worldwide issue, is smart cities are the thing at the moment. There's a lot of attention for, there's a lot of investment in, and cities are thriving. So when cities are thriving, they attract a lot of, people. And you see the cities are really growing fast. Two of the fastest growing cities in the US are here in North Carolina, Raleigh and Charlotte, but also two of the fastest declining cities are here in North Carolina. And, that's the downside of smart cities is that they attract a lot of business, successful people from rural areas around the cities. So it's a worldwide issue, but in North Carolina it's pretty extreme. So we see a very extreme diversion between the cities and the rural areas. So our idea was, how can we, if we want to look how we can connect the developments in the bigger cities, how can we connect that with, developments on the rural areas, so the rural areas will prosper also by what's happening in the cities. And North Carolina is a very good test area for that because the diversion is very extreme. And it's a very interesting state. It has mountains, it has a coastal area, and a middle area. So also geographical, it's a very interesting state as a test state for these issues. So can we make use of innovative technologies like exploiting big data, sensoring, and the Internet of Things? Can we provide marked improvements in socioeconomic environmental health by addressing a range of concerns and using a living lab approach in which research, development, and education are staged with pilot deployments of prototype solutions? So these are mainly, the driving points for our project. Where do I push on? Oh, here we go. So smart and connected communities, why? Well, smart cities, I just said, is a lot of attention for a smart city concept, and the cities are really doing well, attracting a lot of resources, but why? It moves there, but not here, yeah. So, smaller towns and rural areas have a hard time to catch up, and they lose resources, educated family, business capital. So the towns, in general, see a shrinking population. Sometimes not too much, sometimes bigger. We see a rising poverty, diminishing services, lower governmental maintenance, and a literacy gap. When you attract, the people with potential, everybody starts moving out of cities that have diminishing services. So what rests are people are not able to move out. So smart living labs. I want to talk about the living lab approach because my colleague, Professor Arkat Rajaskar, already spoke to you about this project in a different place. So I want to tell you a little bit about how we like to approach this project within North Carolina, and we would like to install smart living labs based on topics that we could research. And smart living labs are often based on an open IT platform, IoT technology, and big data manipulation. So, what are such labs? Living labs, you hear the name a lot, but in general, there are spots or areas to experiment with exciting, innovative ideas. And it can be an open formula. You can have, a living lab and just see what sprouts out for topics or for teams or whatever. Or you can pinpoint it on team. For instance, the inland flooding in North Carolina. Basically, a living lab is a research concept. So it's a user-centered, open innovation ecosystem. It's operating in a territorial context, a city or agglomeration or a region or state in this case maybe, integrating concurrent research and innovation processes within a public-private partnership. And extra P is the people. So in general, a living lab is always based on a public-private people partnership. Can be focused around a specific concern or a thematic group of concerns. So integration of research, creativity and innovation, it's co-creating or creating, it's explorating, it's experimenting, and evaluating innovative ideas, scenarios, concepts, and technologies in real-life use cases. The interesting thing of a living lab is that you can sprout innovative ideas. So you have the team or the problem, but you don't have the solution yet. And there are all kinds of little experiments that you can use to come up with a creative and new innovative idea and solution. I want to look at some of the living lab approaches around the world and just name them. There are many living labs in Europe. It's a big thing, but I found some other as well. In general, multiple living labs method of trialing new smart city technology is a pragmatic approach to understand how different vendor technologies will work in a dynamic and real-world environment. So combining economic development and brand building will draw innovative startups and encourage local entrepreneurialism. And that's something that, you know, might occur in rural areas in North Carolina if we really use a living lab approach. So there are three major projects, living labs in Copenhagen. It's a smart lighting concept. It's actually three little living labs called DOL. Energy labs, and there's a street lab. And the street lab I would like to focus into a little bit more. It's a multi-block region in the heart of Copenhagen that deploys technology for multiple vendors in live city environments. So Cisco is involved. They deploy public Wi-Fi in the area. They provide network access for citizens, but also for tourists. Connect a number of smaller startups. It's really interesting. Environmental centers company, smart parking company, and it's all in the system. And it's an engagement model which is clever and allows Copenhagen to evaluate technologies and production within the city. Also gives smart city technology startups an access to a production test environment. And I heard that complaint a lot here in RTP, the research triangle, where lots of companies are, and the companies are really looking for test beds, and they're none. Cities are not eager to step into that. So living lab approach would be a potential if you combine the cities with companies, with research facilities and universities, and involve the people who are living in that area. You could have a nice test environment for new and innovative ideas from companies. So it promotes Copenhagen as an innovation center. And that's an important marketing tool, actually. So in general, the Street Lab has currently deployed smart city technology for monitoring air, noise pollution, intelligent parking, and waste collection. But of course, you can add a lot more of those similar kind of things. Amsterdam has a smart citizen lab, has many labs, but one is the smart citizen lab and explores tools and applications to map the world around us, right around us. And also these are, they deal with themes a bit similar, like air quality, but even the conditions of bathing water or noise pollution, or you can name it. So lots of people have smartphones or smartwatches or anything else smart, the computer. It's becoming increasingly simple to collect the data around us. So open data and the sensors are also playing a major role in the retrieval of new data. Thanks to today's technology, measuring itself has become much easier. So one of the things they did in 2014, they experimented with the Smart Citizen Kit. It's an open source device that monitors the environment around people. Technology was not yet ready at that moment, but that the exchange of experiences helped us to understand what the possibilities are of a citizen science. Today, the Smart Citizen Kit is actually deployed much more in a broader sense. I just want to go briefly into a couple of things. Helmond is a city of the size of Kinston in North Carolina. Helmond was really successful in using a highway nearby to promote themselves as a smart mobility lab. And Smart Mobility Lab lets also to companies establishing themselves in and around Helmond, and they created an automotive campus. At the moment, most automotive industry of the Netherlands is based on that campus. Some projects that they did is the self-driving cars and actually everything around that. The safety issues, you name it. They had a project Compass 4D, it's optimization of daily traffic. It's a lot of words, Euro NCAP, but that's actually the source of the funding. An innovative crash test developed. So cars in Europe are now going through that crash test instead of the old, physical one. They have an integrated test site for cooperative mobility, so joint mobility. Tien, which is a kind of national lab, investigates ghost traffic jams. Those are traffic jams that occur when there's no measurable or physical occasion that causes it. And a company, Violet, tests their intelligent transport systems. There's a lot of text on this one. I'm really sorry. I want to have the EU focuses also on rural living labs, and one of them is Penella in Portugal. And what can it's a little bit similar to what we're going to do in North Carolina. It's promoting innovation, research developments, new technologies, methodologies, and applications for rural areas, focused on rural areas. It's also the recognition of the weaknesses and constraints in rural context, and they can differ. The interesting thing of North Carolina is they might be different for Eastern and Western Carolina.
We wanted to interrupt. I don't know if you can still hear us, but we can't hear you over the phone anymore. The audio went out.
Okay. You hear me again?
Okay, yes, you just came back.
Okay. Till where did you hear me? This slide?
The last thing we heard was you said it recognizes the constraints of rural areas and the difference in East and West Carolina. That was the last word.
Yeah, well, the goal is to produce knowledge around, the set of activities on local and regional level, on rural level, and using different agents and capable of foster entrepreneurship, economy, quality of life. It's a commitment in the community. Those are terminologies that are used a lot in smart cities, but are not used so common in rural areas. So, trying to set up centers of innovation, good practice, and development on rural sustainability, and focusing on agro-food, forestry sectors, for instance, as a center of economic model in Penella. These are the main sectors, but they're pretty similar here on some areas. So it generated around a model of sustainability with 4 factors, and that's important. It's natural resources, social development and welfare, tourism and identity, of course, citizenship and entrepreneurship. Let's go on to the next slide. Can you click the... Oh, there we go. So this was basically a very brief introduction on living labs and using living labs in North Carolina. The question is, could we use an entire state as a living lab? And what would be topics here for rural living labs or teams? Thank you.
Thanks a lot for your presentation. I'm going to open the floor now for questions.
Welcome.
So I did have a question. I don't know if someone else wanted to, but I will jump in. But so for the different types of living labs in the city and rural settings, the one you talked about in Copenhagen where they had networked, like the parking and the local and tourist Wi-Fi, how are they actually using that in an experimental way? Are they trying to test out if you place things in different places, how does that affect parking in this area, and how large of a section of the city are they able to do that with effectively?
What I understand now is that they do it in it's parking areas in the entire city, and you can see on your phone, for instance, if there's space. So, and you also direct it to the right space in the parking garage or whatever. So it's very interactive. So if I go to Copenhagen and I'm from Holland, I have no idea where the parking garages are. It's leading you to the parking garage that is close to my destination and has space.
Great. Actually, I will be in Copenhagen next month, so I'll test this out, try it out.
Lucky you.
Yeah, and I guess it's a different question on the rural side. What are the distinct, you talked about agro and food and forestry, but is there any part of the Living Lab that's bringing in or trying to combat some of the drain of resources from rural places?
Well, this particular one in Penela didn't focus right on that subject. What they did is by providing all kinds of resources, they would stimulate entrepreneurship and active citizen participation, and that might help people stay there. So, in general, you could see that as a little bit. I don't know if you heard about what happened in Germany. In Germany, little villages lost also their young and educated family members or citizens to the larger cities. And what they did is they installed with subsidy of the government. They installed all kinds of green energy plants on rooftops of the farms, of houses, windmills, etc., etc. And they started cooperative energy organizations, sold the energy to the grid, and by selling it, they made some money, and they used that money to fulfill some of the wishes for young people. And in general, not everywhere, of course, but in general, they attracted more and more young families to stay. And when people stay, not everyone, but some of them will start their own business. And it is a way of stopping the social mobility that is now, emptying those towns or villages, and turn it around into new future for those places, and have more growth. I've been in Kingston lately, and that is not even one of the worst ones. But when you go to the town center, there are many empty windows, and that's not something that attracts people. So how to turn it around? And I don't have the answer yet. That's for the Living Labs. But the idea is that you can keep people more in the towns and villages or areas, and get some more economic activity.
Great. Well, yeah, I definitely want to open invitations for coming to the workshop in Atlanta. It's April 27th and 28th. We want to look at smart cities and smart campuses because some of these issues we found can be piloted on university and college campuses. A lot of they're under the same umbrella where they have the transportation, the bus, the police, the crime, the parking, all in one spot. Some of those campus initiatives are actually trying to do some of these things. So getting together really the doers, and this Living Labs is really a doing initiative of how do you connect not only the sensors but also the infrastructure of the city. This one is more focused on Internet of Things, like sensors, and putting them and getting that type of data to be useful in different communities. So.
Right. I think maybe if you want, I can inform you a little bit more about. I've been working for the Technical University in Delft in the Netherlands and worked on the Green Campus there. And the Green Campus is basically a living lab.
Oh, yeah, that's fantastic.
Yeah. So if you want some information or contact me, and we can talk about it.
Definitely. I think I have your information from the lab, from the actual Smart Cities call, right?
Oh, yeah.
Yeah, Renata, I'll introduce you to Cora via email.
Yeah, my email, I forgot to put it in the slides. I'm sorry, was kind of last minute thing due to a really hectic time. But my email is cor@Strateq, my company, STRATEQ.nl.
.nl?
.nl, yeah, Netherlands.
Awesome. Are there any other questions anyone has?
I have a quick question. This is Beth Zittler again. I'm curious what you've seen to be the most valuable coalitions and partnerships, especially in different contexts. I'm thinking about you and Renata were just discussing how universities can be an interesting kind of test place for some of these things, and I'm wondering what other civic groups or other members of the public are interested in using data or coming up with new ways to understand how their communities work.
Yeah, it's in Europe you see a lot of attention for that by the cities. However, if you look here, you see that that attention by bigger cities, but not by the smaller ones. Yet, it will come, I'm sure. So, in general, for universities, it would be good to partner with groups of companies and perhaps some, local operating GOPs.
Gotcha. I have a background. I grew up in Iowa and have a lot of relatives who still live in rural areas, and they use a remarkable amount of technology. Some of them have automatic driving combines, for example,
Yes.
And they're like people who are members of their board of governors of their electric utility. So I think there's a lot of different neat things that folks are doing that could be informed by data, and they'd probably be pretty receptive to it if the infrastructure existed.
Yeah, so the people are probably more open to it than the governmental systems.
Mm.
I think that's my experience in North Carolina so far.
Actually, can I ask a question to Tien? In terms of something that we've been thinking about is also how cities change over time and kind of the dynamic nature of things. And I was wondering if you could talk a little bit about for these living labs, kind of the time dimension and how things evolve and the dynamic nature of these processes?
Yeah, well, I'm convinced that cities cannot thrive a long time without the environment around it. So there must be somehow a balance between what's happening in the rural areas and the cities. What's happening, you know, we had it that the cities are very attractive at the moment to people, so they attract a lot of young, well-educated people. But some cities grow. Amsterdam, for instance, in Holland grew over 6% last year, and I think New York has something like that too. It means a lot of people entering a city, and it stresses all the services, all the resources that the city has. So if you look at New York and you have a few 100,000 people coming in a year, they need schools, they need medical aid, they need roads, so food, for instance, water, and they get more and more dependable also on the environment around it. And I believe that that what's happening now in smart cities, and smart cities is the thing. Everybody is looking only at the cities and has a lot of attention for it. It is not a sustainable development if you don't have a balance with the environment around it. Is that an answer?
Yeah, I agree. Yeah.
Yeah.
Thanks.
If I may, Gretchen Thompson here at Family Health International, and I'd like to ask a question as an add-on to the need to look at environments surrounding urban areas in terms of sustainable development. And I see one of the topics here at the close of your presentation are, topics for rural living labs. I'm curious what your thoughts are on the potential for our lessons learned from a living lab approach on strategies for broadening what has been sort of urban-centric development to be more inclusive of those rural areas, and how we can perhaps look beyond the scope of just an urban locus of sustainable development to include perhaps those rural regions that surround them. And if you were to tie that specifically to some context within North Carolina, we could look at things such as the Sandhills areas and revitalization in Fayetteville, northeastern North Carolina, and the kind of metropolitan Tidewater area of Virginia. There are a number of centers or regional centers there that I think something like that would be a fertile ground. But I'm curious what your thoughts are on the potential for that.
No, I think they should be included in eventually in somehow in the living labs that will occur. To be honest, I have a very open mind of where this is going to. We do workshops in the Eastern and Western Carolina to find out what are the issues and how can we help, and that will be input for living lab constructions. I can, off the top of my mind, I can put up some topics or things, but I'm not from here, and I might be wrong. So, yeah, it's hard to answer your question for me.
I understand. Maybe this is a better topic for discussion rather than a question. So, I think my own bias in asking that question is I'm curious at looking at how urban centers are very much dependent and linked to the rural areas around them, as you just said. And so when we think about the environment that surrounds cities, those often encapsulate rural communities and people who live in those areas. So you sort of have the spokes and the hub. arrangement between urban and rural centers. And I think being more inclusive of the spokes will be of mutual benefit to both the spokes and the hub, and thinking of how we can do that and how information technology can help us do that. So no answers here either, but certainly an area of interest to me, and I think relevant to your last observation just now.
Yeah, well, that's the scope of the project. The hubs and spoke idea is an element in our proposal for this, or was an element in our proposal, and of course, how can information technology help? Is an important issue. It's you know, the basis of what we are doing.
Thank you so much. Incidentally, I actually grew up in Aden, North Carolina, about 11 miles north of Kinston. So that's an area that has definitely seen quite a bit of urban decline over the past, 30 or 40 years. And I think, they've been caught in the midst of massive deindustrialization across the U.S. South.
Right.
But in addition to that, if you look at present-day Kinston, there's the deindustrialization, but that hasn't happened evenly. And so if you go into southeast Kinston, you're going to see vastly different impacts of that deindustrialization era than you will in, say, other parts of Kinston. And efforts to revitalize that region, like developing the Global Trans Park, which I would venture to say has been a colossal failure, but even where its benefits have rolled out across that region, it's not been evenly so. And so I think that's a really important element in looking at living labs in areas such as Kinston. How do you address the structural inequality, the near, present-day segregation of that community and the work that you do?
I agree. I believe that the whole smart city concept, we have the stage of today's technology gives us, for the first time in history, a potential to build really inclusive cities, inclusive and coherent cities, and that should be also possible for places like Kinston.
Excellent. Thank you so much.
Yeah, Gretchen, also that's a great point, the fact that the effects of some of the either revitalization aren't evenly spread necessarily amongst the whole community, and how that actually works for the city or works for the lifting up of the entire city or just certain pockets or communities. That's really an interesting point.
Thank you, Renata. And I think it plays to, also the observation we've seen with the ability of social media to be an avenue for advancing social justice issues. It's very much in line with this kind of broader decentralization and democratization of these things. So if we can capture some of that through the way that we gather and subsequently analyze data, it's a fascinating way to try and achieve equity.
Right.
Social media, Iris, that's your act as well.
Sorry?
I don't know how social media could be connected. I was just saying it's the connecting.
Yeah, actually, it's interesting that we're talking about this because I actually just had a meeting this morning with some people from the west side of Atlanta. So for those of you who aren't that familiar with Atlanta, so Georgia Tech is located in Midtown and kind of just a mile or two to the west. So Georgia Tech is very kind of, it's a lot of resources and kind of very good infrastructure. But for the west side, as it's called, there's a lot of kind of dilapidated infrastructure, things that there's a lot of flooding that occurs because it's kind of downstream from downtown. And so kind of as we were doing this work on flooding, and I know that they have a lot of flooding issues when there's any even normal rain event. So we thought that that would be a good possible pilot place to collect data using social media actually to enable residents there to be able to identify problems in their community and actually be able to locate them and then have that informed decisions at a higher level in terms of infrastructure investment and things like that. So I think that in So for a community like that, embedding sensors in the pavement or something is not something that is really that feasible. But for us, with using social media data, we thought that that could be kind of a way that they could actually use kind of these new big data sources to inform researchers and also like city officials and things like that about the condition of their infrastructure. So I think it's an opportunity that kind of evens the playing field a little bit in terms of what resources are needed to collect this type of data.
Love that idea. And, you know, I wonder how this plays out in places like northeastern North Carolina where, you know, if you drive down Highway 11 and 13 in between, say, Greenville and then the Tidewater area, and I've made that commute maybe a day with a teenager and a smartphone who was really frustrated for about a good hour, hour and a half, because it's an absolute dead zone.
Oh, so you're saying that some places you can't tweet about because you have no reception for about an hour in that area?
Zero. I mean, zero. There are places in the swamps in northeastern North Carolina where it is nil. You're not going to get cell phone reception, and you darn sure not going to get 3G.
Yeah, you know, because I was loving the idea of Iris when you were talking about social media, because it takes infrastructure investment to get sensors like embedded into cities. So social media is a way to basically use everyone's smartphone as a sensor where people can tweet about what they're doing without doing that original investment. But Gretchen, what you're saying is for rural areas, sometimes that even can't be used as a receiver because there's just these large dead zones. So you may not have any way of getting information about a certain area. So that's interesting too, like looking at coverage, you know.
Yeah.
It's even so.
And, you know, North Carolina they're rolling out some new programs where they're tying internet access through these sort of Wi-Fi hubs. So it might even be a good kind of experiment to look at where that comes into previously dead zones and what kind of difference that can make through perhaps the lower level, you know, ability to get data feeds through social media. There's also some techniques that we've used. So I currently work in global health and international development, where we do it routinely across, you know, really low resource settings. And there are some kind of routine data collection methods that we've set up using SMS technology. I'm not the person to speak as an expert about it, but what I can say is that in areas where connectivity and reception is really very low, it has been an alternate strategy for getting into those areas, and maybe something that could translate into those, you know, very isolated areas, rural areas we're talking about.
Yeah, and I would maybe ask for one more thing with regards to maybe more vulnerable populations, is that even when there is reception, something that we've been talking about is also not everyone has kind of unlimited texting or unlimited data plans, and how do you work with that in terms of these communities that you might be interested in working with?
Does anybody know, I mean, this is just a curiosity, I have no idea, but does anyone know how you do that? I mean, there's two global development people, I mean, Beth and Gretchen, with places where either people don't always have a smartphone or unlimited data plan. How do you even penetrate into those areas? Like, what is something you've seen work?
So what we've done, I'm currently working on a project in Malawi and in Ghana, and what we've done is we work directly with the mobile phone providers. So if they don't have unlimited use of text or airtime, our data collection efforts come along with reimbursement plans or strategies instead to promote their participation. So that's been the primary way we've gone about it through my experience. But another project that I'm not directly involved in, but I'm aware of, is run through the World Bank. It's called the World Bank Listens. And what they actually did was provided cell phones with solar chargers to nationwide representative samples throughout Malawi and other countries in Southern Africa, where they then used those cell phones that they support and provide to routinely collect data.
Yeah, and this is Beth. I think that those comments are all similar things I would say. We oftentimes are working with people whose job is to provide data, and so usually those folks are getting paid by us and have invested in a cell phone for their use. In terms of the coverage, that can be an issue, and there's a number of technologies that have been developed that work offline until you can get access to the ability to upload your data, essentially. And I don't know, that doesn't work as well with this social media question, but it does work for when you're recording information to later add to a map or something like that, or to input into a survey, for example. And we have also paid for internet subscriptions. For example, we did an open gender data competition in Cote d'Ivoire, and some of our participants had a barrier of internet access, and so one of the things we funded, and I think we did it in partnership with a private sector provider. I'm not sure if they donated the time on their network or if they donated funds. I can't remember how they did it exactly, but a local cell phone provider did help us out with that. So.
Just to add, I think this was a similar issue that was happening in Africa, and Vodafone had introduced M-Pesa in Kenya, where they were doing transactions, all financial transactions using an SMS text and a PIN, which created a virtual bank for everybody who had a basic phone with just text services and no data services as well. And I know that was very successful, and now it's in other parts of Africa as well as Asia. That was another way that they went around not having data or having smartphones.
Yep, and there's a couple of, and I'm blanking on the organization, but I'll look it up and add it to the HackPad. There's a couple of organizations who specifically focus on making sure that folks' voices are heard who don't have good internet connectivity, and they've come up with a whole suite of tools and successfully implemented them. And the other thing I was going to say, which is a bit to Arjun's comment, it's possible to set up systems where people who even don't have minutes on their phone, can call a number, and the number will not be answered, but then it will call you back immediately, so that the number that calls you back is charged for the time and not you. So there's lots of ways to get around this.
Definitely.
See, this is why people are getting together. So any of these links, also to the HackPad, also if there are any links to these other communities, boards that you were mentioning overseas, just putting them on the HackPad is also a good place so that there are others, or if we have a forum around these topics, we can always come back to them and link people to these other places, and it can help with the living lab idea, which is a fantastic idea. In bringing resources to anything you guys may try to implement as well.
Yeah.
And I remember the name of the organization. It's called Engineering for Change, and they had a webinar, so I'm adding that to the HackPad.
Thanks.
Yeah, but I just want to add that the rural areas in the U.S. is different from those rural areas in Africa and Asia countries, because the rural areas in those countries are very populated. That's why the mobile phone service providers can make money to deploy the mobile phone infrastructure. But for the rural area in North Carolina, I think it's so less populated. I mean, the Verizon is not going to deploy the infrastructures to make money. So I think it's important to distinguish between different types of rural areas.
Definitely, that definitely makes sense. I'm just wondering if anybody else has any other questions. All right, I think this was a very informative session we had today. If you have any other remaining questions or comments, please add it to the HackPad. And with this, I would like to thank our speakers and conclude our meeting today. And I hope everybody has a great rest of the afternoon and a good weekend.
And thank you, Carl, for setting everything.
Thank you.
Great.